Hello algebra students, this is the first video of the year, Radicals and Exponents. I'm Mr. Barnett and I hope this video will help you to review the topic, preview the topic, will just in general help you to do better in your algebra class. If you're in my class, now would be a good time to set up your notes. The way we can do that is I would like you to start by drawing a line about that. What we're going to do is we're going to set up Cornell notes. So if you're unfamiliar with Cornell notes, the first part you should do is put a title. And like we said before, this is radicals and exponents. Hopefully you can write a little bit smaller than me as I am writing on a computer screen. Right? Add your titles. You can put today's date, and make sure your line is basically divided so you have the left side will be for study questions, and we're going to work mostly in this section right here. This is called the body of the notes. Okay, take a second, get this set up. If you have to, hit pause. Our first topic is radicals. You'll see symbols like this little check symbol thing here. That's called a radical. And what it means in this case, this is called a square root. Now, a square root could have a 2 here, but in general you don't write the 2. Square roots are not the only kind of roots that we'll look at. We'll get more into this, but a square root, if you had to break it into simpler words, would mean what number times itself will get you that number. And that sounds kind of confusing, but if you look at our first example, this is the square root of 144. So to find the square root of 144, we just want to think, what numbers will we multiply to get 144? Now, you could look at all of them, or really what we're trying to do is find what number can you multiply by itself to get 144. With a little bit of thinking, you'll notice that square root of 144 is 12 times 12. So therefore, one of the square roots of 144 is 12. Now that's not the only square root. We also have our negative roots, because negative 12 times negative 12 would also give you 144. But for right now, we're looking at the primary roots. The primary root would be the positive root. And they do relate to exponents because square roots can sometimes undo squaring of a number. So in a way, the exponents and radicals can do opposite operations. Now the reason this is called a square root is if you're thinking of area of, say, a square, if you know that the area is, for example, 144, area for a square is length times width, but with a square all sides are the same. So really what you would do is find the square root of that 144 to find that each side is 12. And 12 times 12 is 144. So remember, this kind of information is stuff that would go in the body of your notes. Now, maybe you wrote down extra things based on what I said, or you wrote down just what was on the screen. You need to write down whatever you can to help you understand what radicals are and how you would use them. Okay? If you need to, you can always hit pause, stop, write down what you need to. But I am moving on. Okay, so the next topic we're going to talk about is exponents. Now, the symbols that you use for exponents, we have, let's get some vocabulary out of the way. This kind of small number that's above the number, that's the exponent. The larger number, that's called the base. And what this case means is this is read as 5 to the third power. And 5 to the third power is equal to 5 times 5 times 5. Those are multiplication signs, those small dots that you can barely see. And the reason why we know that is because 5 is the base, that's the number you're going to keep multiplying, and 3, the exponent, is the number of times that we multiply. So we multiply 1, 2, 3 times. Thus, the exponent of 3. This also works with variables such as x to the 4th power. What's our base? What's our exponent? I didn't hear you. Okay, yes, you are correct. X is the base and 4 is the exponent. So if I had to write that, what that means, it's just x multiplied by itself 4 times. Good job. You're so smart. Now, there are lots of patterns with exponents. Let me look at this a little bit further. Okay, we're going to look for patterns here. So I want you to look at 2 to the third power, 2 to the second power, 2 to the first power. So in case you forgot, 2 to the third power is equal to 2 times 2 times 2. Also times 1. And if you don't understand why we're multiplying by 1, keep in mind multiplying by 1 should not change what the value of our expression is. So just leave it there. 2 times 2 times 2 times 1 gives us 8. Okay, notice that there are 3 2's. 3 is the exponent. 2 squared is equal to 2 times 2 times 1. I know it's not necessary, but you'll see why I'm writing in just a second. 2 times 2 times 1 gives us 4. And 2 to the first power is 2 times 1. 2 times 1 is 2. Now, I want you to look at something before we continue, because what we're going to look at next is 2 to the 0 power. Notice this pattern we have here. 3, 2, 1, 0. Exponents decreasing. What happens with our answer? 8, 4, 2. Each time we are dividing by 2. 8 divided by 2, 4. 4 divided by 2, 2. We're actually dividing by whatever the base is. So it's just 2 this time because I chose 2 as my base. But we'd be dividing by whatever the base is. So let's let this pattern continue. 2 to the 0 power, this is another way you can think of it. There would be no 2's there, but there's only this 1 there that we've been carrying it along, and this is why we've been carrying it along, because 2 to the 0 power is not equal to 0, is equal to 1. That's right. It follows the pattern. 8 divided by 2 is 4, 4 divided by 2 is 2, and finally 2 divided by 2 is 1. Not 0. 2 to the 0 power is 1. And that is true for any non-zero number. If you take to the 0 power, you will get 1. Let me continue this pattern then. So if we kept going, the next one would be 3, 2, 1, 0, negative 1. Because again, these exponents are just decreasing. Well, what are we going to get with negative exponents? That's tricky. Well, I guess the only thing I can look at is continuing this pattern. 4 divided by 2 is 2. 2 divided by 2 is 1. 1 divided by 2 is simply 1/2. 1 over 2. 1 divided by 2. Or another way to write this is we're back to our 1, and since these negative exponents are the opposite of the positive exponents, we're going to do the opposite. Instead of multiplying, we are going to divide. So it's essentially like saying 1 divided by 2 is 1/2. 2 to the negative 1 power is 1/2. Notice that negative exponents do not make negative numbers. They make fractions, or very small numbers. So let's continue. 2 to the negative 2 power continues. Just divide that by 2. So you have 1 divided by 2, and we're going to divide that by 2, and we get 1 over 4. Now, do you notice any symmetry in our patterns here? 2, 1 over 2. 2 to the first is 2. 2 to the negative first, 1 over 2. 2 to the second, 4. 2 to the negative second, 1 over 4. Well, what do you think 2 to the negative 3 would be? I can't hear you. If you are paying attention, look at your symmetry. 2 to the positive 3 is 8. 2 to the negative 3 would be 1 over 8. Got that? Now you might be saying, Mr. Barnett, I get all this. These exponents, they're just they're whole numbers, and then they're integers. Fine, I can deal with that. But what in the world do we do with fractions as our exponent? I don't know. Well, that's easy. Really what you're looking at is when you have 16 to the 1/2 exponent, or 16 to the 1/2 power, that's really, when you look at the denominator of your fraction, that's really just another way to write these radical expressions. So this is the square, or the second root of 16. Again, remember, you don't need to write this 2, it's assumed, but we will be doing other examples with roots besides 2. So 2 to the 1/2 power is really like the square root of 16. And of course we know square root of 16 is simply 4, because 4 times 4 is 16, and ignoring the negative 4 times negative 4 is 16. For right now, we're just looking at primary positive roots.